let's combine what we know about headings, about finding the magnitude and direction of a vector given its components, and finding the components of a vector when you know the magnitude and direction. So here's the problem that I pose to you. A plane flies 240 miles per hour on a heading of 160 degrees. The wind is blowing 80 miles per hour at 25 degrees north of east. Find the plane's resultant speed and heading. All right, we are going to tackle this problem by breaking the airplane vector and the wind vector into components, adding those components together, and then using those to find the new or the combined speed and direction. So let's do two different things. Let's do the plane on this side, and we'll do the wind on this side. So I'm going to draw my coordinate system, and I know this is north, south, east, and west. And we know that the plane flies 240 miles per hour on a heading of 160 degrees. All right, so 0, 90, 180, so 160 is going to be in here somewhere. So 160 degrees. Now, I would propose to you that what we need to do is, in order to find the tail to the tip, we need to know the components. We are going to go in the x direction some amount and the y direction some amount. So let's call this the x component and the y component. And if from north to the vector is 160 degrees, how much is this angle in our triangle? And I think if we do 160 minus 90, we will find that is 70 degrees. So I'm going to clean up my drawing here a little bit. So now we know 70 opposite, adjacent, and hypotenuse is 240. So let's break the plane down. Let's see, we'll call the plane the p vector, and we want to find the x and the y components. All right, so for the x, adjacent over hypotenuse is going to be cosine. So cosine of 70 degrees is adjacent over hypotenuse, and we can multiply both sides by 240, and we get that x equals 240 cosine 70 degrees. And if you pop that into your calculator, you will find it's approximately 82.1 miles per hour. So there's our x component. Let's do the same for the y. Opposite over hypotenuse is sine 70 degrees. Opposite over our 240-mile hypotenuse. And then we can multiply both sides by 240, and we will get y equals 240 sine of 70 degrees, which comes out, using your calculator, approximately 225.5. And so let's write that in, 225.5. Now we have to be very careful here. And when we start at the tip, we go positive x, negative y, so this has to be negative 225.5. Now let's do the same thing for the wind. We know that we need our north, south, and east and west. North, south, east, and west. And this is interesting because it's blowing at 80 miles an hour, but it says 25 degrees north of east. All right, well, let's do this. Of east. So find the east. That's this line right here. And it is 25 degrees north of this eastern line. So our angle is going to be 25 degrees. And our wind is going to be 80. And so we are going to go in the x direction and the y direction to go tail to tip. So we need to find those x and those y components for the wind, which we will call the w vector. So let's see. Let's do the x first. That's adjacent over hypotenuse. So that's cosine. Cosine 25 is adjacent x over our hypotenuse 80. Multiply both sides by 80, and we will get x equals 80 cosine 25. And when you multiply that out on your calculator, you'll get approximately 72.5. So let's write that in. Okay, now we'll do the same thing for the y component. Opposite over hypotenuse is sine of 25 degrees is y over 80. Multiply both sides by 80, and we'll get y equals 80 sine 25. And that comes out to be approximately 33.8. And so we can write that in for the y component. And let's double check the signs. Positive x, positive y. There we go. Okay, so here's what we are going to do next. We want to find the combined plane, which is 82.1, negative 225.5. And we want to add the wind to it, which is 72.5 and 33.8, in order to find the combined airplane and the wind. And so when we do that, we will find that this is 154.6 in the x direction and negative 191.7 in the y direction. Okay, so let's just draw a graph in a sense of what's going on. So we have the airplane that's going downwards in this direction, and then the wind is blowing it back that direction. So that's the tip to tail adding. And so the resultant vector is going to be here somewhere. And so we know to get to that point, according to our matrix addition, we're going to go 154.6 in the x direction and in the y direction we're going to go negative 191.7, and we want to find initially this angle and that magnitude. So that's what we're going to do next. Okay, well, the magnitude should be pretty easy. We can do that using Pythagorean theorem. So the magnitude is going to be equal to 154.6 squared plus negative 191.7 squared, and take the square root. And if you calculate that using your calculator, it will come out 246.2 miles per hour. So then the next thing that we have to do is figure out this angle. Well, we know this is opposite and adjacent, and so that's tangent. So tangent of the angle equals, now we're going to ignore this minus sign. We're just going to use all positive numbers, 191.7 divided by 154.6. And we want to do inverse tangent, and we will come out with an angle of 51.1 degrees. Now, we just want to use positive numbers when we're doing this triangle because we're just dealing with the magnitudes of the components. Okay, and we'll figure out the signs and directions later. Well, here's the thing. If we know that this is 51 degrees, we want to find a heading, and heading always starts at north 0 degrees. And so we would go 90 degrees, and then we would go another 51.1 degrees to get that vector. So 90 plus 51.1 is 141.1 degrees heading. So lastly, we can answer the question. And the question is the resulting airplane speed is 246.2 miles per hour on a heading of 141.1 degrees. It's a very long problem and it has a lot of steps, but each of the steps is really pretty simple, and I know that you can do this. You can put it all together. That's all for this lesson.